Another practice program in data structures and algorithms. Let's go ahead and hop into it. Today we're going to be working on Leetcode 79, which is word search. Given a 2D board and a word, find if the word exists in the grid. And so we have some examples down here and some true or not. Hold on just one moment. We got to start the video up. Oops. The feed. Okay, good. Hey, Pulsating, thanks for stopping in today. So the word can be constructed from letters of sequentially adjacent cell, where adjacent cells are those horizontally or vertically neighboring. The same letter cell may not be used more than once. So you can go like up, down, diagonally doesn't work, but you can't go back to where you were before. So A, B, C, E, D returns true because, A, B, C, C, E, D returns true because we have A, B, C, and then C, E, D like this. SEE also returns true because it goes this way. ABCB returns false. It's not on the board. So if we think about approaches, kind of hop right into it. We could investigate the board, and I'll just come right out with it. It's another depth first search problem that we can do. It is a little bit of a trick. So I did my first stream, which I didn't save, but if you've been watching since day one, we did a count the number of islands stream. And that one you would sync the board. So you have a bunch of ones and zeros, and if the ones are connected, that only counts as one island. And you do a depth first search, and then you change the board. This one is a little bit of a wrinkle on that because we want to reset the board. Basically, if we're looking in one direction, we want to count something as seen, and so we don't want to return to it. But similar to the number of islands, similar to a lot of the depth first search problems, we have an exist function over here, and then we're going to make a depth first search below that's going to check if we're on the board and check if the next letter is actually correct. And if it's not, then we're going to return false. And we're going to advance to the word one letter at a time. So we're going to, like these depth first search recursion problems, we're going to pass this helper function to itself, and we're going to chop up the word as we move along. And if we have some more time and I get a nice solution early on, we can investigate a different way of doing that. Then the big thing with this is that we change the board as we follow along a path, but we need to return back to it. So we're going to actually cast, or we're going to assign a variable called result to the from invoking valid moves on the board. And if we have a lot of time, we might investigate a different way of doing that. Thanks to my buddy Juan, who showed me an interesting and Pythonic way of doing that. Yeah, and then that's basically the long and the short of it. So let's get into the algorithm. So as you're probably getting very used to, if you've been tuning into the stream or been practicing on these Leetcodes, it's a 2D board, so we're going to do a nested for loop for I, and I just woke up from a nap, so this might be a little bit more painful than usual. Range of length of board, very important to remember that. For j in range of length of the column, so we're going to go through rows and calls. The matrix is not skew, so this will be that is we don't have a varying amount of columns, so this will work fine for our purposes. And then we're just going to say if self.dfs, then that's going to take a board, a row, and a call. So up here we have i's and j's. Down in our helper function we're going to have rows and calls. And of course it's going to have the word. So if we have that, then we're going to return true. Otherwise we're going to return false. So that's a very nice thing. But now actually the depth first search function is where all of the thinking comes into, really. And I'm going to go ahead and blame this on a nap. But I wrote the function signature up here. So if depth first search self board row call word up here, in this main function, this is not row and call, this is I and J. I even said that and wrote it anyway. So there you go. So recursion is a little interesting because you kind of have to think about your base case where you end up first when you write these functions, if you're writing it from top to bottom, which you don't have to. But a lot of times I like to. But basically, if we get the, let me think about this. Yeah, if we chopped up our word so there's nothing left, then we're done and we can return true. If that's not the case, we have to make sure that we're on the board. So, and if we're not off the board, we want to return false. So if row is less than 0, or row is greater than or equal to, very important, don't want any off by 1 errors, the length of the board. If I can get the right parentheses. Or call is less than 0, or call is greater than the length of the board, its first element, which is going through the column. So if we go back up here, A, B, C, E, it would be, these 4. Or, so that makes those make sure that we're on the board. Or just where we're looking at is not the next thing in the word. Then we want to turn false. And what we're looking at is the board of row and call. If that does not equal the first element of the word, then we want to turn false. And I'm going to put an enter here. Oops, not there. Just give a little more white space and make it a little bit more readable. Although this line is not super readable, and there's different approaches that you can take with that. So now we want to get to the heat of the meat, and this is something you don't always see all the time, but we want to be able to reset the board. And so how do we do that? Well, one, we need to keep an idea of where we're looking at, and so that we need to make a temp variable. And then we want to say we don't want to return to where we were. So we want to just overwrite that with an empty space. I think empty space will be fine. I'm actually going to make that a character for now that we don't use. I think empty space would be fine, but I want to double check that later. I know for sure making that a character would be good. No, I think empty space is fine. And then we want to do a bunch of our recursive calls. So we want to advance to the next state. So how we go about doing that, hi Cody Eli, thanks for stopping in, is we want to cast the variable. And this is going to look a little ugly, and I think there's some different approaches to this to make it a little bit cleaner. But we basically wanted to try all those different places. So if we go above, below, to the right, or to the left, that's increasing or decreasing the column or the row by 1. So to get that, all you have to do is recursively call this thing a bunch of times, and or the statements into them. So that's trying every direction. And if it's not valid, it'll return false, and you'll bubble up the call stack. If you eventually return true with the word, if the length of the word is 0, then you're done. So we want to keep the board. We want to try row plus 1, call word, and starting from one after the one that we currently are at, like this. And that is exactly what we're going to do, but 4 times. So one, we're advancing the row, which is below, but now we want to try above, and to the left, and to the right. So we'll just do a little copy-paste coding here. 1, so this is row minus 1. Or, okay, so then we do row minus 1, and then we do call plus 1. And we can also try call minus 1. So that's following all those different paths down the depth first search. Then we want to restore the board to a pristine state. So board row call equals temp. And then at the end of the day, we return the result. I think this is going to work. but let's walk through it one more time. Thanks, Lavender JMK, for stopping by. For I in the range of the board, so we walk through the rows, we walk through the calls. We try this. If it's true, return true. Otherwise, return false. We try this for every cell on the board. If the length of the word is 0, we return true. If it's off the board or where we're looking at is not the next thing in the word, we return false. We assign a temp variable. We change where we're looking at. We destroy that so we don't go back to where we were before. We do a bunch of recursive calls and make this the result to see if we get the actual right thing. Restore the board to where we need it to be, and then we return the result. And let's go ahead and try that. Accepted. Good. So if we do more details, /30th percentile for one run. I don't think it's super interesting to try a few different ones. Yeah, let's just do that because I think I'm going to try one that one approach that'll probably speed this up. So the first one was 30th percentile. This one is 61st. Apparently didn't hit the back button. Let's try 3. So 30 and 60, that's average 45. But we don't know what state we're finding the Leetcode servers in. So we don't have a really good judge of which one's faster. One idea, though, is that these slicings, this word of one is like we're chopping up the word as we go along. So if we're looking for cat, first we look for CAT, and then we chop it up, and we only look for AT, and then we only look for T. This might be somewhat expensive. Let's go ahead and look at more details. And 55%. So this is probably around 50th percentile, maybe. 3 runs doesn't give you really a good bunch of statistics. But I think if we... trying to think, there's a few different things that we can do here that we can probably look to clean this up. I'm thinking about which ones I want to try. But let's try... yeah, let's just do an index. So we're gonna have a 0, and spoiler alert, or check my butt alert. I haven't tried this before, so if this goes down in flames, that's my excuse. We're gonna try with index of 0, and we're gonna use that instead of chopping through the result. And I'm gonna time box this to be about 5-10 minutes because I want to try maybe one other thing too. So basically, we do index, and then we change this condition, right? So instead of its length of word equals 0, it's if length of word equals, so if we have CAT, the length of that is 3. So if we have index be, I think it's index plus 1, equals the length of the word, then we're done. I think that might be an off by 1 error, but let's try this first. So instead of changing the word here, we're just going to advance the index. And hopefully we get a correct solution. And then also, if slicing the word like that is expensive, then this could be a quicker solution. But first, let's make sure it is a solution. Runtime error. DFS takes exactly 6 arguments, 5 given. Line 28. So you self board row call word index, self board self board row call word index, self board row call word index, self board row call word index, self board row call word index. Some of your better IDEs would let you know, hey, you're doing something a little bit crazy here. You need more arguments. Wrong answer. False. True. So A, B, C, C, E, D return true. We return false. Let's think about this. Length of word is index plus 1. Let's think about that for a moment. So just the index. The cat is 3. Index. Oh, it might just be index because we're passing it through the index plus 1, and at that point we're done. Let's try this again with just index. Also false. Okay, so you're seeing someone struggle in real time. Length of word 0. Word. Oh, of course. We're also not just looking at the first thing. That would only be it'd be word of index at this point. Yeah. And we might have to revert that off by 1 thing. Oh, good. There we go. I'm just a little surprised that worked. But don't tell anybody. So let's take a look at the details. 41%. Seems like it's faster. 83%, so that's averaging 60 over just 3 times. And 80. So 80, 80, 40 is 160, 200 over 3, 66. So this is possibly faster. It seems like a reasonable thing. Yeah, and I think when you're just changing an index, advancing a number, as opposed to slicing I'm pretty sure those slices they cost linear time complexity compared to what you're slicing your word. Whereas just advancing an index, that's much quicker. That thing's constant time. So that makes sense to why this would be quicker. And my mom wants to FaceTime right now, but I am programming mom. Parents just don't understand. I'm going to try one more thing before I give my mom that call back. If Juan was showing me a cool thing with tuples. My good buddy Juan, and senior engineer, who's helped me a lot. He was showing me an interesting thing with tuples, that you could have a much nicer line on line 30. Check time, 5:48. Okay. So for I, j in range of, and we just want to do those rows and calls. Okay, it's getting a little confusing, but up here we have i's and j's, and in here we have their own i's and j's. Actually, one also showed me this. You have underscores to make this a little bit. We could probably name those better, but let's name those better. We'll call them x, y. Naming is important. So it's 0, 1, right? Or if we're being consistent, it's 1, 0. So we add 1 and then call, and then we try -1, 0, and then we try 0, 1, and then we try 0, -1. So instead of this little monstrosity, we just say result at this point equals result or only one of those things, 1/4 of those monstrosities. So you do board row plus I, call plus j, and I messed up my own variables as I just did. Let's try that again, x and y. The word stays the same, and the index gets advanced 1. And yeah, so we're doing exactly the same thing down here, but I think this is a little bit neater. So let's go ahead and try that. One thing is that we're starting, runtime error. Built-in function has no item get. Built-in function or method object has no attribute get item. Oh wait, sorry. This is not a range. We're just looking in those things. Try again. We're not doing the range. We're actually just accessing those tuples. Cool, that worked. Yeah, I think this is a little bit more Pythonic. If you're in an interview setting, you might not want to do this because it's a little bit hard to understand from the get-go, but I think it's a lot cleaner, right? You don't have a character count here, but you can just see that this is probably like half as much, easier to debug. Let's go ahead and check that beautiful runtime one last time. Only 28%. Let's forget that we did that. But this was word search. I don't want to have this channel just become, hey, let's do another depth first search problem. But it is a very, very powerful technique. It's a little bit tricky to understand. I messed up recently on when I was trying to go back through this problem when prepping for this on how to reset the board. One approach that I think we're not going to have enough time for to go over. This line 21 is also pretty ugly. You kind of have like a master conditional to return false. Another way to do that would be to kind of have this logic flow through in line 21 down to where we're looking at like 929 or line 930, line 32, where we split these. And I'll just write one of these like real quick. So yeah, it would just be, we'd have 4 of these up here. Or they would actually come down here. So if row 0, then you would try this one, and you're safe because the row is sorry, we'd flip this. If row like this, okay, so that's a little confusing, but basically, and then up here we wouldn't have this big nasty thing. You'd only be checking for if the board row call is the word index. You'd be removing these 4 conditionals, and then you'd have 4 ifs down here. I mean, that's probably personal discretion, but let's understand it's a conditional before we go too much into it. If the row -1 is greater than 0, we know we're on the board. Then we know that we're clear to do this one, and we can just do this conditional right here to test if it's true or false. And you do the same thing if it's row +1. It's got to be less than the length of the board, and so on. The downside is then your code up here, you're trading like one long conditional for 4 in a row. And I'm not sure, honestly, which one I prefer. But, maybe that's getting down too much in the weeds. So this is word search, given a board, going in horizontal and vertically if you can find the letters in the word. Another example of depth first search approach, this time with replacing the board as we move through it and as we find things. And this was Programmer Mitch doing Leetcode number 79. Thanks for tuning in, and I hope to see you next time at 5:30 p.m. EST. Catch you later.